Yep. This is your acceleration worksheet. All right, so what we've got here are two formulas for acceleration. Acceleration equals the final velocity squared minus the initial velocity squared over 2 times the change in distance. Girls. And then, get one from up here. Then we have acceleration equals final velocity minus initial velocity over the change in time. So they both solve for acceleration, but notice on this one we have delta d in the denominator, and on this one we have delta t in the denominator. So if one of your questions is asking for delta d, how much distance was traveled, then you're going to use this formula. But we need to solve for distance. If your question is asking how much time went by, you're going to use this formula, but we're going to solve for time. So let's go ahead and do that. Let's solve for distance here, and then we're going to solve for time. To solve for distance, the first thing you're going to do is rewrite the formula. Acceleration is final velocity squared minus initial velocity squared over 2 times the change in distance. Okay, I'm solving for the change in distance. I want to get distance up into the numerator. How do I do that? I've got to multiply each side by 2 times the change in distance. I got to get it out of the denominator. Cancel out 2 times the change in distance. And I'm going to rewrite the formula up here. So I've got 2 delta d times a is equal to final velocity squared minus initial velocity squared. What am I solving for again? Distance. So that means I have to get rid of what? A and 2. So how do I get rid of them? I'm going to divide. I've got to divide out 2, and I've got to divide out a. Whatever I do to one side of the equation, I have to do to the other side of the equation. So I'm going to divide out 2a over here. Cancel 2, cancel acceleration, and we've done it. We've got delta d, or the change in distance, all by itself on one side of the equal sign. Now I'm going to rewrite the formula down here. Delta d is given by final velocity squared minus initial velocity squared over 2 times acceleration. Alrighty. On this formula, we're going to solve now for delta t, change in time. So the first thing I'm going to do is rewrite the formula. Acceleration is final velocity minus initial velocity over delta t. What is my first step? That's right, I got to multiply by delta t. I got to get it out of the denominator. I can't solve for something that's in the denominator. I need it up in the numerator. So I'm going to multiply by delta t here. Whatever I do to one side, I have to do to the other. So multiply by delta t here. Cancel delta t. Rewrite the equation. Delta t times a is given by final velocity minus initial velocity. Now what do I do? Divide out a. I got to get rid of a, so I'm going to divide out a here. Whatever I do to one side, I have to do to the other. I'm going to divide out a over here. Cancel a, and we've done it. Delta t is given by final velocity minus initial velocity over acceleration. And I was about to put a box by it. let's look at our first problem. Grace is driving her sports car at 30 meters per second when a ball rolls out into the street in front of her. Grace slams on the brakes and comes to a stop in 3 seconds. What was the acceleration of Grace's car? All right, 30 meters per second. What variable is that? Which velocity, final or initial? That's our initial velocity. What's our final velocity? 0 meters per second is final velocity. She comes to a stop. And our time? Very good. So which formula are we going to use? The second one. Okay, acceleration equals final velocity minus initial velocity over the change in time. And this one's very easy. We just plug in. Final velocity is 0 meters per second. Initial velocity is 30 meters per second. And change in time is 3 seconds. 0 minus 30 is negative 30 meters per second over 3 seconds. Now look at these units. We've got seconds in the denominator of the numerator, and then seconds down here in the denominator. When we have this situation, the units will just combine together. Negative 3 divided by 3 gives us negative 10, and the unit we end up with is meters per second squared. That's what I meant when I said they'll combine together. They multiply together. They don't cancel each other out. So there's our answer, negative 10 meters per second squared. Why negative? That's mathematically why it's negative, but what does that mean for her car? It's decelerating. Very good. This is a deceleration.
So is this a trick question because it's asking what the acceleration is?
It's a type of acceleration. It's a negative acceleration, so we call it a deceleration. It's not a trick question. It's just, what does that negative sign mean? It tells you that instead of velocity getting faster, velocity is getting slower. It's decreasing. Example B. Calculate the distance traveled by a truck that accelerates from rest to a speed of 3 meters per second down a ramp at an acceleration of 5 meters per second squared. What are we looking for? Distance. Okay, so we're going to use the delta D formula. Accelerates from rest. What does that tell us?
The initial velocity is 0.
Initial velocity is 0 meters per second. Final velocity? 3 meters per second. And we have acceleration 5 meters per second squared. So our formula is right here. Change in distance is final velocity squared minus initial velocity squared over 2a, 2 times acceleration. So we have 3 meters per second squared minus 0 meters per second squared, which is going to end up being 0, right? So we can just toss that one out, over 2 times 5 meters per second squared. So 3 meters per second squared is going to be 3 meters per second times 3 meters per second. And I'm expanding it out like this on purpose so you'll see what we do with these units here. 2 times 5 meters per second squared, that's going to be 10 meters per second squared. 3 meters per second times 3 meters per second gives us 9. And watch what I do with these units here. I'm going to write them out in expanded form. 9 meters times meters over seconds times seconds. And I did that on purpose. Over 10 meters over seconds times seconds. Now, in this case, one of the meters will cancel with this meter down here in the denominator. Both of these seconds will cancel out the seconds in the denominator. And the unit that we're left with is the meter. What variable were we looking for? Distance. So thank goodness we got meters. 9 divided by 10, and that's going to be 0.9 meters. Alright, so that's how far he traveled. Now I'm going to give you help on the rest of them. Calculate the acceleration of a car in miles per hour squared that can go from rest to 60 miles per hour in 10 seconds. So we've got rest, that's an initial velocity, 60 miles per hour, that's a final velocity. Notice we want to know how long in 10 seconds. But when we apply it to this formula, it needs to be in hours. So the first thing you need to do on this one is convert seconds to hours. So we've got 10 seconds over 1. You're going to convert it to minutes. Then you're going to convert it to hours. And then whatever you get for hours is what you plug into that acceleration formula. Okay. Now on number 2, calculate the speed in meters per second at the 10-second mark for a car that accelerates at 2 meters per second from a position of rest. So you are looking for final velocity here. You have time, you have acceleration, you want final velocity, and initial velocity is going to be 0. So acceleration is final velocity minus initial velocity over the change in time. I'm going to let you be challenged on this one. See if you can solve for final velocity. Not now. Later. Number 3, a dragster going at 15 meters per second, there's the initial velocity, increases its velocity to 25 meters per second, there's the final, in 4 seconds, there's the time. This one is very straightforward. Acceleration is final minus initial over time. Number 4, a car going at 30 meters per second, there's the initial, undergoes an acceleration of 2 meters per second squared, there's your acceleration, for 4 seconds, there's your time. What is the final velocity? Alright, again, you're going to use your acceleration formula and you're going to solve for final velocity. Be careful because in this case, initial velocity is not 0, so you can't just take it out of the equation. You have to be able to plug it in. Make sure you solve for the variable before you plug in to the equation. Number 5, how far did the car go in question number 4? Here's your delta D formula. Change in distance is given by final velocity squared minus initial velocity squared over 2 times acceleration. Number 6, While driving his sports car at 20 meters per second down a 4-lane highway, Eddie comes up behind a slow-moving dump truck and decides to pass it in the left-hand lane. Alright, so here's our initial velocity. If Eddie can accelerate at 5 meters per second squared, there's our acceleration, how long will it take to pass the dump truck at a final speed of 25 meters per second? Here's our final velocity. So on this one, we use the time formula. So it's going to be change in time is equal to final velocity minus initial velocity over acceleration. Okay, have fun. These are due on Wednesday.